Hello, welcome to this lesson. At the end of this lesson, you should be able to define sequence. You should be able to find the nth term of a sequence. And if the nth term is given, you should be able to find the terms of the sequence. So follow as we continue this lesson. Please remember to click the subscription button. So when we talk about sequences, we mean a set of numbers arranged in a particular pattern. Okay, a sequence is a set of numbers in a given order which follows a particular pattern. Okay, and this pattern is called rules. So sequence of numbers normally follows a particular pattern which we call the rule of the sequence. Okay, all right, so sequence of numbers are set of numbers in a given order. Set of numbers in a given order. Okay, so when a set of numbers follows a pattern and there is a clear rule for finding the next number in the pattern, then the set of these numbers is called sequence. Okay, full stop. So we have a pattern and we have the rule for generating the sequence. Okay, now consider the following examples. Example 1. We have 1, 2, 3. Example 1, we have 1, 3, 5, 7, 9. Okay, so in this sequence you can see that the second term differs from the first term with 2, the third term differs from the second term with 2, and so on and so forth. So this sequence has a rule which is continuous addition of 2. Okay, so each number in the sequence is called a term of the sequence, and the nth term of the sequence is usually denoted by un, where n is an element of positive integers, or n are natural numbers. Okay, so this is an example of a sequence, and the rule is addition of 2. So if you add 2 to 1, you have 3. If you add 2 to 3, you have 5. If you add 2 to 5, you have 7, and so on and so forth. So this example is a sequence. Another example, we have 1, 4, 9, 16, 25. Okay, this is also a sequence. If you rewrite it, you have something like 1 square, 2 square, 3 square, 4 square, 5 square. Okay, so this is the sequence of natural numbers. Okay, and the next term can be 6 square, 7 square, and so on and so forth. So this is also an example of a sequence. So as we said, the term in the sequence, the numbers in the sequence are called term. Okay, so and the nth terms of the sequence is usually denoted by un. So nth term equal to un, where n is an element of natural number or a set of positive integers. Okay, So these are sequences, and that is an example of a sequence. Now let us look at the following examples. Example 1. Write down the first 3 terms of each of this sequence. Okay, we have A. Write down the first 3 terms of each of this sequence. For A, we have the nth term is given as 3n plus 5. Okay, so the first term, which is when n equals to 1, so that will be u1. So substitute 1 for n. We have 3 times 1 plus 5, which is 3 plus 5, which is 8. We are looking for the first 3 term. When n equals to 2, we have the second term u2, which is 3 times 2 plus 5, which is 6 plus 5, which is 11. And when n equals to 3, we have u3, which is 3 times 3 plus 5, which is 9 plus 5, which is 14. So the first 3 terms of the sequence are 8, 11, and 14. So given the nth term, you can find the terms in the sequence. Look at example 2. B. un plus 1 is given as 4un minus 7. Okay, un plus 1, for B we have un plus 1 equals to 4un minus 7, and u1 is 3. u1 equals to 3. So we are looking for u2 and u3. And remember the formula: un plus 1 equals to 4un minus 7. Un plus 1 is the term immediately after un. Okay, so now given u1 to be 3, u2 will be, that is u1 plus 1 when n equals to 1. When n equals to 1, we have u1 plus 1, which is u2. So and u2 equals to 4u1 minus 7, which is 4 times 3 minus 7, which is 12 minus 7, which is 5. Okay, now following the same pattern, when n equals to 2, we have u2 plus 1, which is u3. So that means u3 equals to 4u2 minus 7, which is 4 times 5 minus 7, which is 20 minus 7, which is 14. So therefore the first 3 terms of the sequence are 1, 5, 14. Okay, the next example, look for the first 3 terms of the sequence given that un equals to n minus 3 into n minus 1. So when n equals to 1, we have u1 to be 1 minus 3 into 1 plus 1. Okay, this is a minus 2 multiplied by 2, which is minus 4. When n equals to 2, we have u2 equal to 2 minus 3 into 2 plus 1, which is minus 1 multiplied by 3, which is minus 3. And when n equal to 3, we have u3 equals to 3 minus 3 into 3 plus 1, which is 0 multiplied by 4, which is 0. Therefore the first 3 terms of the sequence are minus 4, minus 3, and 0. So given the first term, guys, you can find any term, or given the nth term of a sequence, you can find any term of the sequence by substituting the value 1, 2, 3 for n. Now consider the next example. We are still looking for the first 3 terms of the sequence. Okay, so consider this D. u1 equals to minus 1, un plus 1 equals to 3 over un plus 2. So let us find u2. So u2, we'll have u2 since un plus 1 is the term immediately after un. Then when n equals to 1, we have u2 equals to 3 over u1 plus 2. Okay, so guys, this is 3 over u1 is minus 1 plus 2. Minus 1 plus 2, guys, will give us 1. So u2 equals to 3, and when n equals to 2, we have u3, which is equals to 3 all over u2 plus 2, following the formula, which is 3 over u2 is 3 plus 2, and this will give us 3 over 5. Okay, so therefore the first three term of the sequence is minus 1 or minus 1, 3, 3 over 5. Okay. Yeah, so taking e, for e we have un equals to 8 minus 2n all over 3 plus n. Un, for e we have un equals to 8 minus 2n all over 3 plus n. Did I copy correctly? Yeah. So when n equals to 1, we have u1 equals to 8 minus 2 over 3 plus 1, which is 8 minus 2 over 4, which is 8 minus 1 over 2, and that will be 16 minus 1 over 2, which is 15 over 2, which is actually 7.5. When n equals to 2, we have u2 equals to 8 minus 2 times 2 over 3 plus 2, and this will give us 8 minus 4 over 5, which is 40 minus 4 over 5, and that will give us 36 over 5, which is 5 and 36, we have 7. Okay, yeah, and 5 in 10, we have 2, 7.2. Yeah, 60 minus 1, 2 here, 7, 10. So this one is 7.2, the first one is 7.5, this one is 7.2. Then the third term, when n equals to 3, so u3 equals to 8 minus 2 times 3 over 3 plus 3, which is 8 minus 6 over 3 plus 3, which is 6. So 6 over 6 is 1, so 8 minus 1 equals to 7. So therefore the first three terms of that sequence is 7.5, 7.2 and 7.0. Okay, yeah. So this is how to find any term of a sequence given the nth term. Another example, let's call this example 2. An expression for the nth term, nth triangular number, is n into n plus 1 over 2. Write down the 20th type triangular number. So what we simply do here is say un equals to this formula, triangular number all over 2. Okay, so the 20th triangular number, that will be n equals to 20. So we have u20 equals to 20 into 20 plus 1 over 2, and guys, this is 2 here, 1, 2 here, 10. So we have 10 into 21, and by the time if we open the bracket and multiply that, we have 210. So therefore the 20th triangular number is 210. Okay. Write down the nth term of each of the following sequence. Now if you have the sequence, how do you find the nth term? Okay, so that is our next thing here. So listen and listen carefully here. Listen and listen carefully. So the sequence we have here, for A, we have sequence 7, 13, 19, 25, 31. Okay. Now, so how do we get the nth term? How do we generate the nth term is the question we have at hand. So how can we generate the nth term? So let us go by this way. Now write down the first term. Okay. Just write down the first term. Okay. Then write down the second term. Now if you look at the difference between the second and the first term, the difference is 6. Okay. The difference is 6. Okay. So if we have a 6 plus 1 will give us 7. Now 6 plus 1 will give us 7, right? Yeah. Now 6 times 2 plus 1 will give us 13. Okay, are you following? Or we can say from number 1, let us say for 7, the difference between 7 and 13 is 6. So to obtain 7, if we multiply 6 by 1 and add 1, we have 7. To obtain 13, we multiply 6 by 2 plus 1, we have 13. Then the second one, the third number will be 6 times 3 plus 1, and the fourth one will be 6 times 4 plus 1, and for 31, that's 6 times 5 plus 1. So of course up to the nth term. For the nth term, un will be 6 times n plus 1. Okay, so therefore the nth term of this sequence is un equals to 6n plus 1. Okay, that's for A. Then for B, the sequence we have in B are 7, 4, 1, minus 2, minus 5. For B, we have the sequence 7, 4, 1, minus 2, minus 5. Okay, so write down the first term, the second term. Now the difference between the second and the first is 3. Okay, the difference between the second and the first is 3. So how can we obtain 7 from 3? So that is simply 3 times 2 plus 1. Okay, so 3 times 2 plus 1 will give us 7. Now how do we get 4, 1, and so on from this? So let us define a formula for this. Now 3 times 2 plus 1 will give us 7. Okay, 3 times 1 plus 1 will give us 4. For 1, we have 3 times 0 plus 1. Good. And for minus 2, we have 3 times minus 1 plus 1. For minus 5, we have 3 times minus 2 plus 1. Okay, yeah, I think this rule is working. So we can generate that up to un, which is 3 times minus n plus 1. Okay, so therefore the nth term will be un equals to minus 3n plus 1, which is the same thing as 1 minus 3n. Okay, are you following, guys? write down the first term, write down the second term, find the difference between the first and the second, and express that difference as a multiple of a number that will continuously generate the next term, and then you derive a formula, and then you continue. Another example, we have C. Sample C, the first term here is 1/2, the second term is 1/3. Now, finding the difference between 1/3 and 1/2, we can subtract this one. So this is 2 minus 3/6, which is minus 1/6. Okay, so how can we generate the next term here? So the first term is 1/2, second term is 1/3. So let's say this is 1/2 plus 0. This is 1/2 plus 1. 1/4 is 1/2 plus 2. 1/5 is 1/2 plus 3. Okay. Yeah. I think the formula is working though. So the next one, 1/6 is 1/2 plus 4, and up to the nth term, 1 or un, let me not say un equals to 1/2 plus what are we getting there? This is n minus 1. Okay, for first term we have 2 plus 0, for second term we have 2 plus 1, so this is 2 plus n minus 1. Okay, 2 plus n minus 1. Yeah, that will give us this. First term, second term, third term, and the fourth term, fifth term, sixth term. So this is 1/2 minus 1 plus n, which is 1/n plus 1. So therefore un equals to 1/n plus. Alright guys, so the nth term of this sequence is 1/n plus 1. un equals to 1/n plus 1. Let's take the last example. Minus 15 minus 4, 7, 18, 29. Minus 15 minus 4, 7, 18, 29. 7, 18, 29. So write down the first term and write down the second term. Now the common difference between the first and the second is minus 4 plus 15, which is 11. Okay, so we have multiple of 11 something. So this is 11 times 1, or minus 11 times 1 minus 4. Okay, I think so. So minus 11 times 1 minus 4 will give us minus 15. Minus 11 times 2 if we put 11 here, we have this. So this is, it can't be minus. So if we have 11 into minus 1 minus 4, we have this. So 11 into 1 11 times 0 minus 4 will give us this. 7 will give us 11 times 2 times 1 minus 4. 18 will give us 11 times 2 minus 4. And 29 will give us 11 times 3 minus 4. So we can do this up to the nth term. So you can see this is the first term, second and third term. So un can be 11 times n minus 4. So un equals to 11n minus 4 for this sequence. So if you like our videos, please remember to hit the subscription button below. Remember that sequence is the arrangement of number according to a given pattern, and this pattern is called the rule for generating the sequence. Okay, the numbers in the sequence are called terms, and the last term or the nth term of the sequence is called the un. Okay, the un. Right, remember to click the subscription button below and put on the notification for our next video, which is series. Bye.